Okay, look at question 105, 105a. Okay, before that you look at b. Actually this is plus, not minus. So you can change it, 105. Part b, actually the answer is plus, no, not minus. Okay, so I'm going to do part a. Evaluate this one. Okay, equal to k ln 5 minus ln 2 minus 3 over 2, where k is a constant to be determined. That means you want to find what is the k. Okay, so we are asked to integrate. So how are you going to do this? So you look at this. Okay, so we are going to integrate this 1 2 like that. So in order to integrate this, you see, actually we can do like this. We are going to do like this. You see, if I want to integrate this, I can do like this. Wait, just a minute. If I differentiate this one, you see the bracket is here. Then I can have a 2 here. Differentiate x squared, I have a 2. Okay, and then this one I just put a half. Correct? It's a constant. This is correct. But the problem is, you integrate ln, what do you get? We don't know. That's why cannot. Okay, that's why cannot. This is correct. This is half is correct. But the problem is ln become what? That's why we have to use, whenever you see ln, you have to use integration by parts. So I told you already, I say when integration by part, you have to use u dv. You must know which one is the u. I told you already, when involve ln, this will be the u. Remember. Okay? Other than ln, this will be the u. Only for ln, this is the u. So u equals to ln, then I differentiate, I get ln negative 1, then I differentiate 2x, then you get this. Then dv will be x dx, integrate, I get this. Okay? Then only I substitute. So you see, when I want to substitute, I just write all the brackets there. I just show you all the bracket there. Okay? Then only you substitute. So when you substitute from here, from the red color here, you substitute, and then after that you get this one half, this one, you get this minus. Okay, when you come to this is a fraction. Remember, fraction we must always change to proper fraction. This is improper. So how to change to proper fraction? You have to do the long division like this. Okay, so you do long division, you get x cubed x, you get x cubed, then plus x. So 0, you get negative. So after that, you will get this. You will get something like this. Okay, you see, I show you. You will get something like this. Is it? You see. Just look at this part. Okay, so you look at this. Is it improper fraction? So you will get this is half, same, x squared, or this. And then this one, when you change to proper fraction, you have x minus x over this. So this one already become a proper fraction. Then we can start to, you see, here I start to substitute 4 ln 5 minus, then I substitute 1, I get ln 2, isn't it? Then here when I integrate the x squared, I get x squared, I integrate x, I get x squared over 2. And then when I want to integrate this, negative become plus, is it? Then this one become x squared plus 1. Now I want to integrate this, negative 1. In order to integrate this, I have to differentiate this. I get 2x, and then I add a half. This is correct because this is a constant. Then this one can be done. That's why you get this 2 ln. Okay, this one you multiply in is 2 ln 5, and then half ln 2. Then this one I substitute 4 over 2 half. Then here I can integrate half, and then negative 1 become ln. This negative 1 become ln. Then x squared plus 1. Then I substitute the 2 and the 1. Then I get this 2 ln 5 half. Then this one is 3 over 2. Then this one I get this like this. I substitute. Okay, I substitute half. I get ln 5 minus 2. Then I simplify. Then you get this. That means according to the question here, if you look at the question here, they ask you to find what is the k, isn't it? They ask you what to find k ln 5, isn't it? So what should be the k here? Okay, you look at here. what should be the k here? We look at the answer. The k is 5 over 2 lah. You see, exactly the same. The k is 5 over 2, then minus ln 2 minus 3 over 2. So the k is 5 over 2. Okay? Okay, now we go to the next one. It should be question number 50 something, is it? Okay, question 50. Look at question 50. Now we look at question number 50. I show you the question first, then I will show you how to get it. Here, question 50. Question 50, you are asked to show, that means you have to integrate this. You want to show the answer is this. Hence, find the value of this. And then you want to get to 3 decimal places. So first you want to do this, after you want to do with the square. Okay? So I show you how to get this. Okay, this is question 50. Okay, so you look at here. Question 50. I just close this one. First you want to find this. Okay, question 50. You want to find 1 to e x ln x dx. So here, of course, we are going to use integration by parts. This, because we involve with ln, this is the u, then du is 1 over x dx, and then your dv will be x dx, then you integrate, you get this. Then after that, I told you already, you write down all the 4 brackets like that, because this definite integral, 1e, 1 to e. Okay, then after that you substitute the u, the v, everything substitute. Then after that you get this. Half you take out. Then this one you simplify, you get x. Now this one can integrate easily. Then you substitute all the value, e square ln e, this one ln 1 is 0. Then the half x square over 2. Then you get this one e square. Ln e is 1, this is 0. Then here you get 1 quarter, this is 1 quarter. Then e square minus 1, then you get this, therefore you get this. Okay, so this is the first part where you are asked to show, isn't it? You are asked to show, this. And then hence find the value of this. Now you want to find this value. So how to do this? Okay, we want to show. Now you come to this. Okay, you see here. Now you have x ln x square. Okay, so now this is the u. The u is always involved with the ln. Remember that. Okay. Then you can start. U is this one. Then the du you differentiate. 2 you bring it down, ln x. Then you differentiate the ln, you get 1 over x. So you get this. And then the dv will be x dx. Then you integrate, you get this. Then after that you want to use the formula for integration by parts. Then you substitute the u, the v, everything you substitute inside. Then here you can simplify, isn't it? So you can simplify. After that you will get something like this. You see, I show you. I continue here. You will get something like this. So that easier for you to check. You see, after this, I will get something like this. Okay, so this one cancel, the 2 and the 2 cancel. Okay, here I get half, take out half, x square ln x square e 1 to e minus. Then this one is cancel also, the x and the x square, you get x ln this. Okay, so this value actually you have to integrate again, isn't it? But no need, because from part 1, the previous part we have already found here. That's why they use the word hence. You don't have to redo again. Just take the answer here and substitute. That's why I substituted the value here, and then here what I do, then I bring down the value from here, I put it here, isn't it? I bring down the value from here, I put it here, and then here I get half e square ln e is 1, and then ln 1 is 0, that's why I get 0. Therefore you get half e square like this. Okay, this one, that's why you get this finally. And then you are asked to find 3 decimal places, use the calculator, you get this answer. Okay.